Hi everyone, my name is Amy Hernandez, and today I want to talk about two different approaches to teaching science by comparing two classroom vignettes focused on the moon phases. These examples show the difference between a traditional teacher-centered approach and a inquiry-based student-centered approach, and why current research supports a shift toward inquiry and discovery learning. So in case one, we take Miss Sheridan's classroom. Miss Sheridan uses a traditional approach to teach the moon phases. The lesson begins with her introducing key facts such as the moon's 28-day cycle and the names of the 8 moon phases. Students are asked mostly recall-based questions, and their primary role is to listen and remember the information being presented. Miss Sheridan explains the content in detail and uses a diagram on the smartboard to walk students through the moon phases. While students do participate in hands-on activities, using flashlights and balls to represent the sun, earth, and the moon, the activity is very structured. Each group is assigned a specific moon phase and then given a diagram to follow, rather than being encouraged to explore or discover the concept on their own. Learning is reinforced through flashcards and a quiz that focuses on memorizing terminology and facts. This approach is efficient for delivering content, but it does offer limited opportunities for critical thinking and student-led exploration. So in contrast, in case 2, we go to Miss Lee's classroom. Here in Miss Lee's classroom, she shows a inquiry-based approach. Here, students study moon phases over an extended period by observing the moon and recording their observations each day. Learning is guided by open-ended questions, such as why the moon appearance changes as it orbits the Earth. Instead of providing direct explanations, Miss Lee encourages her students to discuss their ideas, ask questions, and work together to figure out the answer. Students design and use models with props to explore how the sunlight reflects off of the moon and how this changes throughout the orbit. Learning takes place in a variety of ways, including group discussions, visual representations, gallery walks, and collaborative explanations. This approach allows students to actively make sense of the phenomenon and develop a deeper conceptual understanding. As we know, research strongly supports inquiry-based science instruction. According to the Arizona Department of Education, effective science teaching involves engaging students in asking questions, investigating real-world phenomena, and using models and explaining thinking with evidence. These strategies encourage collaboration, discussion, and equitable participation, helping all students build deeper understanding and critical thinking skills. This approach is grounded in the theory of constructivism, which explains that students learn best when they actively construct knowledge by connecting information to what they already know. Constructivism emphasizes hands-on experiences, reflection, and social interaction. Miss Lee's classroom clearly reflects this theory because students build their understanding of the moon phases through investigation, collaboration, and evidence-based reasoning rather than memorization. When comparing the two approaches, the differences are clear. Traditional instruction places the teacher at the center of learning and emphasizes content delivery and recall. Inquiry-based instruction shifts the focus to the students, encouraging exploration, discussion, and sense-making. Inquiry-based teaching is also more inclusive as it provides multiple ways for students to engage and demonstrate understanding. Culturally responsive teaching strengthens inquiry-based instruction. Culturally responsive teaching values students' identities, experiences, and ways of knowing as assets in the classroom. In traditional settings, cultural identities may be less visible due to standardized teacher-directed instruction. In contrast, inquiry-based classrooms like Miss Lee's allow students to share ideas, collaborate, and bring diverse perspectives into the learning process. Being aware of personal biases and recognizing students' strengths helps create an inclusive classroom where all students feel valued and supported. As a future science teacher, I plan to incorporate inquiry and discovery by designing lessons that begin with meaningful questions, encourage investigation, and allow students to collaborate and explain their thinking using evidence. By doing this, I can help students see science as engaging, relevant, and accessible, rather than something to simply memorize. Thank you so much for your time, and have a great evening.